No? Okay. Okay. So, welcome to CHEM1210. This is a course that's a survey course, a principal course that's going to survey a little bit of general chemistry. We're going to get into the really heart and soul of chemistry, which is called organic chemistry, which is my passion. I love organic chemistry. I get to teach this class, the second sophomore level, and then advanced organic chemistry. So I just love organic chemistry. It's one of my passions. Hopefully, as you leave this class in, 11 weeks, 10 weeks, you'll also have a passion for, or at least understanding as to why chemistry is kind of cool. Some of you probably had a bad chemistry experience. Kind of left a bad taste in your mouth. All that boring stuff like oxidation reduction and stoichiometry and balancing chemical equations and memorizing what magnesium nitrate looks like as opposed to magnesium nitrite and all that fun stuff. Hey, Hannah, are you in here? Sweet. So all that to say, one of my passions is trying to really inspire you to see chemistry in a brand new way, more than that pedantic, dry chemistry world that some of you might have come through, okay? I've dedicated my life to the study of one atom, and that atom is number 6, carbon, okay? So my expertise is in carbon chemistry. That's what organic chemistry is. Organic chemistry isn't very difficult. It really, hey, Jack, good to see you. It only deals with 3 atoms, really. Carbon, nitrogen, and oxygen. There's organic chemistry for you. So we're gonna have to set a foundation on which those 3 atoms make sense. Oh, that's right, yeah, you switched, yeah, okay. I'm like, wait a minute, I just had you. You're gonna hear all my stories again. So with that, I want to hopefully show you how that thing on the wall, first it's incorrect, but secondly, how that is a window into a real awesome understanding of reality, okay? And then once we see that window, we're gonna narrow the window down a little bit. We're gonna see life through a really small little window, and it's called carbon, all right? So this is really what this course is about. How do we understand that atom? What makes that atom so special? What makes it so amazing? What makes it so difficult? Organic chemistry is still that weed out course for medical school and dental school and graduate school, and it's a tough course. It's a big deal when you take a year-long sequence of organic chemistry at the 3000 level. It's stressful. A lot of students have to take it 2 and 3 times to get a passing grade. What makes it so difficult? It's only 3 atoms, but it's the combination of those atoms which absolutely makes the miraculous structures that we call the body, organelles, and life. So I'm going to take you on a journey because I love teaching. I tell my students always that there are 3 things I'm very passionate about. You're going to get a lot of Jesus in here. I love him. I am trying my best to follow this guy because I think he's really cool and he's amazing and I think he is who he said he was. All right? So we're going to get a lot of him in here because I cannot divorce science from Jesus because he is the great Lego master that put this all together, and I believe that. All right? Secondly, very passionate about my family. Family's pretty cool. All right? So those are my 3 kiddos right there. My smoking hot wife. She is an OBGYN surgeon. She has delivered over 2,000 babies. She works at St. Luke's downtown. A lot of my nursing students will say, hey, Dr. Anstein. I'm like, yeah, the real Dr. Anstein. So they get to work, we interact with her, which is really kind of fun. I'm the secondary Dr. Anstein. It is pronounced Anstein, not Anstein. I think this is where my parents really messed up. They should have named me Frank. I still think to this day, had they named me Frank instead of Tim, it would be Frank Anstein, which I think would be the coolest thing to have that name. Dr. Frank Anstein, please report to the OR. I just think that would be such a cool, come across the hospital intercom would be just awesome. So with that, we're going to delve into some general chemistry, some organic chemistry, and some biochemistry. Okay, so we're really covering a lot. We're doing this like 60,000 foot flyover. So we're going to cover a lot of material, and it's going to be very thin. All right. Sophomore level organic chemistry covers not as much, but it goes deeper. Advanced organic chemistry covers that and goes really deep. So we're just going to skim across the top of this, and we're going to have a really awesome understanding of general chemistry, organic chemistry, and biochemistry at the end of the semester. Sound good? My job is to make class interesting, okay? And I try my best to make this fun because there are some lectures that are boring, and I will do my best to make them not boring. This is one of the boring ones when we have to take roll and go over the syllabus. Not very exciting, but we have to do it. It's part of my job to make sure you're here, and I have to check a box. I do not take attendance other than the first couple of days, just because the registrar wants to just be able to count who's in the class and who's not. So we will take attendance once we go over the syllabus. So let's hit the syllabus, and let's talk about a few things that we're going to be going through in here as the semester progresses, kind of the organization of this thing. All right, so let's go over the exciting syllabus. I have a couple rules in my class. Some of you aren't going to like me for it. That's the way it is. We're going to work with this. Very standardized class. We're going to have exams in here. We have a couple assignments in here. Like I said, my responsibility is to make lectures interesting. I worked in, so my background is in biological organic chemistry. I have a bachelor's degree from Point Loma in biology, and I have a second one in chemistry. So I know the realm between biology and chemistry fairly well, because I have both those degrees. I fell in love with organic chemistry, so I went on and got a PhD in organic chemistry. I did a postdoctoral fellowship in photoorganic chemistry at UC Berkeley, and then I moved from Berkeley on to Elan Pharmaceuticals, which was Nurse Corporation at the time, and I developed advanced pain drugs, pain medications, and I'll integrate those into lecture because there's some really interesting stuff that we did. We actually discovered a pain molecule 10,000 times more potent than morphine that has no addiction and no side effects. It's an absolute miracle drug. And I'll explain how we found that, how that works, and with as we move on within the context of more of chemistry or organic and biochemistry. So when I lecture, I try to lecture in the realm of more through the lens of a biology major. I know now that this is our second year that we have field biology majors in here. That's kind of cool. We have, I think, like 15 of you in here, so it's pretty neat to have you in here. They changed the curriculum a couple years ago, so the wildlife biology majors don't need to take the full sequence of general chemistry and organic chemistry. They can take 1200 and 1210, which is a nice sequence. Okay, so my lectures, I put a lot into them. All right, I typically will lose the PowerPoint. I lecture with 3 colored pens on the whiteboard. Okay, I don't like PowerPoint. I think creativity died when they invented PowerPoint. We used to teach through story. That's how it was done for thousands upon thousands of years. And when we took story out of teaching and learning, I think we killed it. Because that right there, it's a picture of me on Mount Rainier and my family. What are we doing? We're looking at something. We're not engaged. We're really not engaged in that. This is the part of the story. So my lectures have a lot of story to them because I think that really engages. I have students come back year after year saying, "Hey, I remember that lecture you did about blueberries." And I'm like, "You remember what an aldehyde is?" Just out of curiosity. I'd like that you remember blueberries, but story is what we remember, right? Just think of your own journey. When you're at the highs and lows, right? You remember that trip where your dad locked the keys in the car and you had to wait 4 hours for AAA to show up, right? You remember that, right? Because there's emotion tied to that. There's your body, your soul, your mind is all engaged in the highs, the tragedies, and the triumphs of life. And so that's why we're wired for story. There'll be assignments in here. I'll announce them ahead of time. I'm not going to surprise you with anything. I don't do pop quizzes or anything like that. You will have to have an active Achieve account. Okay. If you pull up our Canvas portal, it's right here. So it looks like this. If you go to our syllabus is the first site on there, and this link right here will take you to an Achieve account. That is our course, so you need to fill that out and have that get up and running with that. Some of you are already probably used to that, but if you're not, you need to set up that account for 1210. That's this course. Okay, so that's our homework. There'll be 4 exams. You can look on the back and see exactly when they're going to be. You can put them on your schedule. I follow this pretty closely. Okay, maybe a day off or 2, but typically we're pretty dialed in. You can put your little planners and nail that down to know when those are going to be. All right, I think I got it right this year. I didn't have us having Monday off last spring, so I think I fixed that one on January 17th there. Okay, there'll be a final exam in here. It is National Standardized Exam in GOB sequence of chemistry. It's made by the American Chemical Society. It's a fantastic exam that I can assess this class and how I need to change things or how you're doing relative to other schools in the nation. Because this is also, unfortunately, it shouldn't be. I'm trying to argue against it, and hopefully somebody will be successful in that. This is still considered a GE science course. Again, it shouldn't be, but it is. Because of that, we have one more extra layer of homework we have to do. We have to actually understand the scientific method, okay? Because that is one of the outcomes to a general ed science course, is that you can articulate the scientific method, okay? So towards the end of the semester, we'll have a little breakout on that. Might even have a little fun thing that we do, and then we'll have to write up a little thing that I have to grade and fill out a rubric, and it goes off to somewhere that I don't even know. Okay, so with that, I will explain that more as it goes on, but that is something that we're all going to have to work through together. So you can see kind of the breakdown here of the grading, and if you have questions, just let me know. Now, here's where you're going to be really excited. I am not a fan of laptop computers in class. I don't believe unless you have a tablet, you're actively taking notes, you need a laptop in front of you. I really engage with eyes and students. And when I see a student doing this, and the student behind them also watching what they're doing, I doubt you're taking notes, okay? If you do have a tablet that you're gonna take notes with, I'm okay with that. If your computer's open, just so you can check your email and keep your Instagram account active and check things like that, I would ask you not to use your laptop. If you do need to use your laptop, you can step outside and use it. It's very distracting as a professor to see all these people with their laptops open, looking here, not engaging with me, okay? That's one of my pet peeves. I like to engage. I look at eyes. I used to look at faces. I'm now looking at eyes, and I love seeing faces, okay? So I will engage with you, but I typically don't, and you can come up and talk with me after lecture today if you want to make a case for why you should have your laptop, that's fine. But I really feel like there's very few reasons why we really do have to have a computer on and open in the classroom, okay? That's just my policy, all right? And again, I'm willing to make exceptions if you can rationalize why, all right? So I would ask for that, okay? There is a syllabus addendum on Canvas. You can go ahead and read that. That's about being integrous and all the things about plagiarism and all that extra stuff that we used to add to our syllabus, but we quit doing that. So there is an addendum on there if you want to go on to the Canvas site and do that. Okay, any questions over anything we want to talk about so far? Good? Told you this was an exciting day. Okay, let's do roll. I'll just do it here. Cal, I'm sure I'm going to butcher your name, so just bear with me. Skylar? Here. Okay, cool. Samuel Allen? Here. Brian Bach? Here. Caitlin Bach? Huh, that's cool. Bach? Is it Bach or Bach? It's also Bach, huh? Just different spellings. Cool. Savannah Baldwin? Lily Brown? Emily Bueller? Cool. Your chemistry. Awesome. Cool. Why didn't I know that? That's awesome. That's cool. Abigail Carr? Here. Where? Here, okay, cool. Christian Carter? I think I saw you up front. Yep. You go by what, Chris? Or do you go by Christian? Cool, yeah. Cool. Erica Tanner? Right there, okay, cool. Henry Clark? Cool. Abigail Dwan? Dwan? How do you say it? Dwan. Here's Dwan. Okay. Hannah Evans? Back there. Hi, Hannah. Oh, that's you, yeah. It's funny, I didn't know your last name. I've known you, what, for now, a year? That's cool. Hi, Hannah. Claire Ferguson?
Here.
Cool. Corinne Fernandez? Cool. Jonathan Floor?
Floor singer.
Floor?
Yeah, it's like
Floor Shinger, okay. Floor Shinger, right?
Yeah.
Cool, cool, okay. It's actually just the way it's spelled, cool, I just butchered it. Lacey Flood? Hi. Grace Gertis? Jack Green? Cole Hamlin? Chloe Harris? Okay. Christian Hawks? Hannah Henderson? Cool. Kimberly Humes? Michelle Isabel?
It's Ellie.
Oh, I'm sorry, that's your middle name. Cool, Kayla. Kara Jensen? Kara? Kyra, okay. Okay, Marie Kamameto? Okay. Reagan Kelly?
Here.
Okay, cool. All right, Kieran?
Here.
Is it Kieran?
Yes.
Okay. Kranzau?
Cran.
Cran? Gunther Mansfield? Mansfield, okay, cool. Carolyn Mahon? Okay. Gabriel Miles? Graciela Monreal? Oh, Rosa. Alyssa Moore? Alicia. Okay. Peyton Motter? Jaden Oldenkamp? I know that name. Anastasia Fazzoni? Okay, cool. Kinsey Ritchie?
Here.
Is it Jerome?
Yeah.
Jerome?
Yeah.
Rihari?
Rahari.
Say it again?
Rahari.
Rahari. Okay, cool. Lauren Schneider?
Here.
Eva Schultz? Mackenzie Shepard? Emily Spickelmeyer? Is it Spickelmeyer? That's cool. Adam Stallings?
Here.
Cool. Aaron Dinson?
Here.
Oh. Gotcha. Austin Wall?
Here.
Isaac White? Darcy Wilkins?
Right here.
Shulker Wilkins? Shulker? Brianna Williamson?
I go by Bree.
Bree, okay. Olivia Williamson? Okay, cool. And Avery Yates. All right. Okay. No, that's done for now. Okay, exciting. All right, so let's jump in. Let's take a look at some. Let's take a look at a little bit of chemistry this morning, or this afternoon, I guess it is. So we're done in here right at 1 o'clock. So. We have a little bit of time to go over some fun stuff. So one of the big questions I get in a course like this, a survey course, a principal survey course, is why am I taking chemistry? Why do I really care that I'm taking, why do I really care about chemistry? Why do I care about the periodic table? And I'll just say right now, you don't have to care about the periodic table. My challenge to you is just like windows are opportunities to see something through something. All right? C.S. Lewis used to say, if we didn't have windows, we wouldn't see what's out there. Right there, we don't have a window. We can't see the quad. We can't see the statue of Jesus. We can't see the student union because there's no window there. We put a window there, we're going to see something through that. We see through windows. And to me, the periodic table is a fantastic window through which we can see life. We can see the architecture of life. We can see the hardware that runs life. We can't see the software, which we will talk about, because we are a ternary code. We're going to get into coding, which is a super fun part of this course, called DNA. But we have to have a window if we're going to see into the way this universe is put together. That's why we're taking chemistry. We're taking chemistry to see something bigger, really, than just atoms. Those atoms are organized in a real dynamic way, all right? So we're going to see that chemistry takes us into a lot of different realms, right? We're going to study the behavior of matter. We're going to see how matter interacts. Here's the crazy cool thing. 99.5% of all chemistry is simply the movement of electrons. That's it. So we probably should know something about electrons. I am looking right now at each of you, and all I'm seeing is your electron suit. That's it. These are our electron suits. All we're seeing in each other is electrons. And the reason why we have different colors like pink and red and beige and orange and white and blue is because of the way photons interact with that electron. Okay? So we see color because of that interaction of photons and electrons. So how is it that I can have this broader understanding of the movement of electrons, of what electrons are doing? Well, that's what we're going to begin to build on. We're going to go back into general chemistry. We're going to cover 3 chapters in general chemistry just so I can set a foundation on which organic chemistry makes some sort of sense. Because right now, if I just jumped in with alpha, beta, polyunsaturated diethyl ketones, you would have no idea what I said. So we have to build. We have to begin to learn and speak the language of chemistry. It starts with things like hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, all these things that we call atoms. We haven't defined that yet, but we're going to look at that. So chemistry is broken down into 4 disciplines. It's broken down into general chemistry, organic chemistry, and biochemistry, and then physical chemistry. Okay? Chemistry is the central science. So chemistry, its subtitle is the central science. So chemistry sits here, in the middle. Okay? Chemistry. On top of chemistry is biology. Okay? Chemistry stands on physics. Right? And all of this stands on mathematics. Mathematics is not a part of science. Okay? Mathematics is before science. Mathematics is the objective side of science. Science is the philosophical side of science. Okay? And we'll get into a little bit of those. What I mean by there's operational science and there's origin science. And they're different sciences. Okay? And I'll explain some of that as we move and as we see this. So you can see that chemistry sits right in the middle. So wildlife biology majors typically deal up here on the top part of biology with full-blown animals. Okay? Your microbiologists and your cell biologists are closer to chemistry because they're dealing on a smaller scale. Organic chemistry is right about here. Okay? It's more biological than something like general chemistry, which looks a little more like physics and needs a little bit more math. So what we're doing in here is we're setting a foundation, again, through a window on which hopefully organisms, animals, make more sense. And when you get into the nursing majors, when you get into your pharmacology courses, and you start to see molecules, I mean, you might look at a molecule, you may look at all the way over here. I don't know if I can because I got that thing going. You know what? I'll be right back. I can't lecture with an orange pen. I'm so sorry. I can't even see it. I'm looking at it. I'll be right back. so when we look at this realm, because most of us in this room, we're going to be spending more of our time right in through here, okay? But again, general chemistry, organic chemistry, biochemistry would be how we break this down. Physical chemistry is going to be down in this realm here. We'll talk about different things like the Schrödinger equation and Bohr's atom and kind of interesting things like that. But here's the cool thing. When you look at a molecule, we haven't really defined molecules. We're still just kind of intro here. But let's take a molecule that some of you probably know. It's still the #1 pain drug administered. It's a fantastic molecule. When I shattered my ankle water skiing several years ago, after surgery, the nurse came in and jabbed me with this stuff, and it was fantastic. It just goes, it's like a warm sensation going all the way up through your body, okay? So this molecule here is an organic molecule. And right now this doesn't look like much to you, but by the end of this sequence, you're going to look at that and go, cool, I actually know a lot about that right now. Yeah?
Is that ketamine or fentanyl?
Ah, neither. Good guesses. This is #1, morphine. Morphine is #1. Fentanyl looks like this. And fentanyl is a really important one because it's massively in our society right now and being abused in our society. This is fentanyl. So that's fentanyl. You can see how they're different. Right? They're in the opioid family. They're both in a similar family. But here's the cool thing about morphine. Morphine has a hydrogen and an oxygen. Carbon, 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 carbon. Oh, organic chemistry. Carbon. Oh, and it also has a nitrogen. Well, isn't that weird? It's made out of 4 atoms. It's made out of a hydrogen, a nitrogen, an oxygen, and a carbon in kind of a weird scaffold. And you walk over here since you brought it up, fentanyl. Well, it's also made out of carbon, 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 nitrogen, carbon, 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 hydrogen, nitrogen, oxygen. Huh. Carbon, nitrogen, oxygen, and hydrogen. Those are the main building blocks of life. They're the main building blocks of the drugs and the molecules that you'll administer, that you'll work with, that you'll learn. So we probably should understand those, because they also are the major components that make up bodies, life. All right? But here's the weird thing that gets really cool. Morphine has a really bad side to it. It has a sinister side. What is it? Yeah?
It relaxes your nerves, and it's also kind of brain fart, but it makes your respiratory rate go down.
Okay, but it's got a really sinister side. That's not necessarily bad. We can control that with dosing. What's its really bad side?
Addiction.
It's highly addictive. Okay? Highly addictive. Okay? So, what I would do as a scientist, as a chemist, is I would look at a molecule like this and go, how can we start to remove some of the things on this molecule or modify things on this molecule to take that bad side away, the sinister side away? Oh, one of the things I can do is I can remove that hydrogen and I could put a carbon on it. I can put a carbon on it and I just decreased its addictive properties. It's called codeine. But here's the problem. Codeine is only about 1/10 as potent as morphine. So yes, I removed some of its addictive side effects, but I also killed some of its activity. And I could be really sinister with this and take that off and take that hydrogen on and put this on, and I just made one of the most addictive compounds in our society. And we want to take a stab at that? Nope, fentanyl's right there.
Oh.
Yep. And fentanyl's a huge problem, by the way. Yep. And you. And I want to take a guess of one of the most addictive in our society?
Is it oxy?
No, I'll show you oxy in a sec. Nope. Okay, those are opioids. Ooh, okay, now methamphetamine looks like this. That's a great question. And methamphetamine would be such an easy one to make. Okay. That's methamphetamine. And the reason why methamphetamine is so crazy addictive is because it mimics our brain molecule called dopamine. This is one of your brain molecules, and you can see how methamphetamine mimics that. It has the nitrogen, carbon, carbon, nitrogen, carbon, carbon. So it mimics that, and that's why it gives you the euphoria, right, artificially. But no, not there. This was actually very popular. This molecule was very popular in the 19th century.
LSD.
Not LSD. I'll drop it out. No, not LSD.
Cocaine?
Oh, I love cocaine. Seriously, no, cocaine. Cocaine is an awesome molecule. This. That's cocaine, all right? It has a slightly different structure. Okay, good. We're getting there. We're just going to go through all the street drugs right now. What about freebasing? What about crack? What about? Anybody else want to take a stab at it?
Is it opium?
No, no. Oh, we're getting closer. It comes from opium. Heroin. Boom. This is heroin. Okay? Heroin is a synthetic analog of morphine. Morphine's the natural, the one you get from the opioid, and they acetylate. Okay? Put acetylene groups on it. My wife is constantly seeing patients that are positive for meth. She doesn't get a lot of cocaine. That's still kind of an expensive powder. Not a lot of fentanyl either, but a lot of. She sees a lot of patients that are positive for heroin and for methamphetamine. All right. So here's the thing. Someone brought up oxycodone. Oxycodone. Go back and see. You can see what's going on here. I'm just trying to show you why it is that understanding carbon, nitrogen, oxygen, hydrogen is kind of an important thing. Because have I drawn anything but carbon, nitrogen, oxygen, hydrogen? That's all organic chemistry. You see how small that window gets? It's not the entire periodic table. I haven't put molybdenum up there, right? I haven't put cesium up there. I might put fluorine on there. There's a couple antipyretics that have fluorine on them. But you can start to see that, oh, to understand how this affects the body, how this affects culture and society, how this affects people in a positive and a detrimental way, it comes from carbon, nitrogen, oxygen, and hydrogen. So that's what we're going to build on. We're going to build on that. Now, oxycodone is a very interesting one. Watch this. Oxycodone. Oxy meaning I got rid of that. Codon meaning I took that oxygen and I made a double bond right here. So this is oxycodone. Okay, so it modifies that part of the molecule, but you can see how they're all similar to the basic natural morphine molecule. And these are all synthetic analogs. Now, here's why I think chemistry could be taught poorly or it can be taught correctly. And I'm going to argue that I'm going to try to teach it correctly. How many of us can count to 118? I hope everyone raises their hand. Okay, good. Me too. That's chemistry. Why do we complicate it? We count from 1 to 118. Okay? Now, where I think it gets complicated is we use weird words. We don't say 1, we say hydrogen. We don't say 2, which would be a lot easier. We say helium. We don't say 3, unfortunately, we say lithium. We don't say 4, we say beryllium. You see where I'm going with this? Okay? That's why when you look up there and you see that blue number, that's all it is. That's the number. And what we'll see is the number of electrons and the number of protons. It's very important. Like I said, the absolute mass majority of chemistry is the movement of electrons. That's why that blue number becomes important. But here's the weird thing. That is not the periodic table. When you look at this, okay, and I was going to show you, we're going to be spending time here, we're going to organic, and then we're going to move